All right, we're looking at circles and properties and graphing them. These are all in an implicit formula, which means that it doesn't directly say what y equals. And so we're using the implicit formula for a circle that x squared plus y squared equals r squared. And of course shifted, that is x minus h squared plus y minus k squared equals r squared. Notice that both the h and the k are backwards from what you would expect them to be because they're both inside the parentheses being squared. And so we're supposed to find the center and the radius of each. The center will be how much it got shifted by from 0, 0. This is centered at 0, 0. And the radius will be the square root of whatever constant it's equal to. So, for example, in number 5, let's do number 6 instead. Number 6, the center will be at -5, 10, and that's because it got shifted 5 to the left and 10 up. The radius is going to be 3. So this ends up having a graph that looks like this. And it's going back to our main equation, x minus h squared plus y minus k squared equals r squared. Okay. Numbers 9 through 10 are a lot harder. We'll notice that these are not in a transformation form. And so what we're going to do is we're going to get them in transformation form. Our first step is we're going to get all the x's together. So I'm going to move everything to the left side. Here's x squared. I'm going to add 26x to both sides. And I'm going to separate that from everything else. I've got y squared. I've got 28y. I'm going to separate that from everything else. And on the equals, I'm going to move the 364 to the other side of the equation by subtracting 364. And what I'm going to do with this is I'm going to complete the square to turn it into a square of binomials just like it was in the other ones. So this is x plus, the way completing the square works is, remember, a square binomial will square the first one, multiply these together and double it. And so if these are getting multiplied together and doubled, this number needs to be 13. X squared, 13 times x is 13x, doubled is 26x. But we've not completed the square. We need to actually make it be a square binomial. And so this number will be 13 squared, which is 169. We used this technique earlier in the year when we were changing things into vertex form. And we said if we added 169, we needed to subtract 169 to cancel it out. One nice thing we can do is we want this constant to end up over on the other side, so it can be part of the r squared. And so we're going to end up adding that 169 to the other side to move it. Another way to think about it is, if we add 169 on the left side, we can also add 169 on the right side, and it keeps the equations balanced, right? We're going to do the same thing for y. This is going to be y plus 14 squared. Again, I know this has to be 14 because when we multiply these together and double it, it has to give me 28y. And so the number we need to make this a square binomial, we've got y squared plus 28y, and then we have to square the last one, that's 196. And if we add 196 on the left side of the equation, we also need to add 196 on the right side of the equation. And so we get equals negative 364 plus 365 is 1. And so we haven't answered the question yet. The question was, what was the center and the radius? The center is negative 13, negative 14. Again, both are backwards from the transformation. And the radius is 1 because the square root of 1 is still 1. All right, I think I'll do one more from the ones in the back. We need to identify the center and the radius. So A, center is negative 1, 2, because both the x and the y are backwards. So 1 to the left, 2 up is going to be at negative 1, 2. The radius is going to be 3 because it's the square root of 9. B, we want to rewrite this as an explicit formula for y. That means we need to solve for y. This is implicit. We can figure out what x is and y is based on each other, but we want an explicit formula that literally says y equals. We want to get y equals something. And so we're going to solve for y. We're going to do it first by subtracting x plus 1 squared on both sides. And so we end up getting y minus 2 squared equals 9 minus x plus 1 squared. We're going to take the square root on both sides, and this is something we need to be careful about. When we take the square root on both sides, remember that it could be either a positive or a negative. So y minus 2 equals plus or minus the square root of 9 minus x plus 1 squared. And finally, we can add 2. Plus or minus the square root of 9 minus x plus 1 squared plus 2. This is actually two separate equations. One equation is the positive square root, 9 minus x plus 1 squared plus 2. And the other one is negative square root of 9 minus x plus 1 squared plus 2. Now let's graph it. We can graph it, I think, most easily using the original equation, the implicit formula, because it's just a circle centered at 0, 0 with a radius of 3 shifted to the 1 to the left and 2 up, which is where we said our center was. Has a radius of 3. 1, 2, 3 in all directions. We can draw our circle from there. And what we should notice is that this also fits the explicit formula. The explicit formula, this top half of the circle is y equals the positive square root 1. That's what's going on here. And the bottom half of the circle is the bottom square root 1. So that's why we have these two equations for these two halves of the circles. Hopefully that's helpful.